Here we go, Chapter 2 of CCNA1, configuring a network operating system. Okay, so it starts off with saying all of these four things are in your home router, which we call a ISR, Integrated Systems Router, or Integrated Services Router. So it's a router, it's a switch, it's a wireless access point, and it's a firewall. And so in this class, we're looking at bigger, beefier things that handle more traffic than your home network, and so they're all split out, and so we have to learn how to program them. So I guess let's start off with what we're going to learn in this one. We're going to explain the purpose of Cisco IOS, explain how to access and navigate Cisco IOS to configure network devices, describe the command structures of the Cisco IOS software, configure host names on a Cisco IOS device using the CLI, use Cisco IOS commands to limit access to device configurations, use Cisco IOS commands to save the running configuration, and explain how devices communicate across the network media. Configure a host device with an IP address. Verify connectivity between two end devices. Okay, for this chapter, I'm going to ask you guys to download Packet Tracer because it would be kind of handy to have as you go along with there. And to go to that, you go out to the course content. If you go home, and as I said before, this hasn't been launched yet, but you have the same buttons. You'll just be seeing this when it's launched. And we go to Student Resources and download Packet Tracer. Okay, and so then download the one for Windows. Cisco Packet Tracer 7.0 probably. You could do 6.3 if you wanted to. And download the one for Windows. And what that's going to do again is give you this virtual application where you can actually program. And so now if you double click, you actually get into where we would be consoled, and then you press enter, and this is the CLI, which we are going to get to in a second. Okay, so we're going to keep going. Okay, the operating system, the Cisco IOS. Alright, so all operating systems are composed of a shell, a kernel, and then the hardware. And so that's what the user is going with. There's two types of operating systems. We have a GUI, such as Windows, as you're seeing, right? We have a mouse and a clicker and a pointer. And then we have a CLI, command line interface, right? And so CLI is like this. So I type enable and I go to a different mode and I say configure something, or actually I always do configure terminal here, and then I could configure interfaces or other things. So this is, or like in Windows we'd say, you know, this is like command prompt. Anyways, so that is let's see, the shell is the user interface that allows user to request specific tasks from the computer. The request can be made from the CLI or GUI. GUI is pronounced GUI. Alright, so then we have the kernel communicates with the hardware and software. So this is where the drivers and whatnot for the hardware are. And then we have the hardware, your RAM, your CPU, your memory, and all of that. So those are what make up the operating system. And now let's find out the purpose. Alright, so the purpose of the operating system is to allow you to operate the machine, right? So be that being use a mouse, view output on a monitor, enter text commands, select options within a dialog box. Actually just use the operating system, period. Okay. Location of the Cisco IOS. Okay, so the Cisco IOS stands for Internetworking Operating System. Alright, and so the Internetworking Operating System is stored in this thing we see right here, which is called flash. This is flash memory, and this is 64 megs of it. The flash memory, then, so just like Windows, we boot up, right, and where is Windows actually running? Part of Windows is running on RAM. All your fast processing is ran through RAM, which is random access memory, right? So that's everything that's fast. That's volatile memory, and so it can be, it's lost when you're shut off. But the operating system starts in this thing. This is where it's stored. This is like your hard drive, but of the Cisco device, right? Because these routers, switches, all of them, they are a computer. They just are doing a different, they have a sole task of switching or routing or being a firewall or an access point, whatever. But so this is the hard drive, known as the flash memory of a Cisco router. And then as you read down here, it'll tell you it is copied into RAM and all kinds of good stuff. Feel free to read that. Alright, so what does the iOS do? Well, it, just as Windows allows us to go to the internet and, I don't know, make Word documents and do all these things, the iOS gives us many features, right? So we can do security things. We can create these ACLs that we've talked about. We can enable QoS. We can primarily, every router, we're going to enable a routing protocol or static routing, right? It's a router, so it routes. We're going to address our interfaces. We're going to give them what's called an IP address, which we'll be learning about in the future. And we can see how much resources we're using and program our interfaces to do all of this stuff. Alright, so that's the functions of the internetworking operating system. Alright, so why don't you guys take a look at this video on your own. And anyway, so when we get one of these devices out of the box, we have to program them, right? They're blank. And so how we do that is an out-of-band, what we call out-of-band management, known as console, okay? And so out-of-band, there's two out-of-band, and that is console and aux port. And the aux port actually does a modem that will dial back in, and this is for emergencies. If you crash your router there and you're in Lewiston and your router is in, I don't know, Afghanistan, you can auxiliary port into the back of your router and hopefully program it and fix it when you've crashed your network. Because this console is typically, it's for really bad scenarios where you have to run to a closet and access the device, or where you are initially programming this device. We just pull this out of the box, so we'll console in. And otherwise we can telnet or SSH, and those are in-band management. And so to do this, we need what's called a terminal emulation program, and I guess I'm getting ahead of myself. That's going to be coming up, so we'll just keep going. But we'll go back to console. Alright, so these console cables, we plug this into the serial of our computer. A lot of computers these days don't have serial, so we do a USB to serial. But anyways, it's serial, which is an old networking technology that we don't use anymore. We use this Ethernet standard. It's much faster, but we still manage these things based on that. So here we go. So telnet, what telnet is if I want to log in and management after I have this device set up and programmed. Say I want to change the programming, something changes, or I'm having a problem. Telnet and SSH allow me to do that. They allow me to remote into the device and make changes or do whatever I want after it's been set up. Remember, the console for initial configuration, Telnet and SSH, because you're going to be a CCNA certified person, you could just program that thing. You know it's going to work because you're certified. You're going to throw it into a rack, and then it's going to start routing, and when you want to change something, you will hopefully SSH and not Telnet, because the difference between the two is Telnet is unencrypted traffic, so a network analyzer can show everything you're doing, where SSH is encrypted. Alright, so SSH is secure shell, it's encrypted, remote access to a Cisco device or computer, and Telnet is just remote access, unencrypted. Alright, so now how we do console or SSH or Telnet. We use a terminal emulator, and this is PuTTY, and this is probably what we'll use primarily in class. And so as you can see, you don't have to do much. You just type in here the IP address in this box right here, and then you click SSH. And so what that looks like in the real world is something like this. Why do we use PuTTY more than anything else? It's free. And so as you can see, we can do SSH, and so what do is I type in 192.168.1.1 or something like that, whatever the IP address is that I'm going to telnet to, or SSH to, and I say open. If I want to telnet, I do the similar thing. As you can see, it changes the port number. This is the TCP port number for telnet. 22 is the one for SSH. Then if we want to serial, we do it like this, and we say, hey, are we hooked into COM port 1, COM port 2, COM port 3? How would you find that out? Well, we'd go something like, well, this is Windows 10, so it's a little worse, but we'd say devices and printers, right? And let's see, I don't think I have my console hooked up right now, but if I did, it would tell me under devices and printers what console port I was currently hung into. And so, but if you're in Windows 7, you just click right there, and devices and printers will be right there for you. Alright, so moving on, terminal emulation, that's PuTTY. This is TerraTerm. TerraTerm is also free. They're all good. TerraTerm, if you're having bugs with PuTTY, I use TerraTerm. I switch back and forth. It just depends what you like, but the most popular is probably PuTTY. Secure CRT, I believe this is for Mac or something. That's Ubuntu. No, I don't know. It's either Linux or Mac. No, I guess Mac is just OX terminal. You can actually just use the OX terminal in Mac, and then Hyper Terminal is a legacy. It used to be very popular. Cisco would send it out for free with all their devices, and then they decided that they were going to charge for it, so everybody went to PuTTY and TerraTerm. Alright, so you can do this activity on accessing devices if you would like, but we're going to move on. Alright, so now we have these different modes of the iOS. So what do these modes mean? And so I'm going to bring our handy dandy little packet tracer over here, and this is router. And you see where we see just this caret right there? This is what we call user exec command, alright? And user exec gives you very few commands. You can ping, you can do limited shows. It'll show you, which show commands are just, you say show interface, and it's going to show you information about your interface, and you don't have to worry about a lot of these show and that kind of thing yet. It's coming. So, and then, so this is just user mode. This is for, I don't know, maybe they don't give you any privileges at work, and so they just want you to ping and see if you can do stuff. And then you have to elevate. So then you go into enable mode, and usually we have this passworded, but this isn't programmed. So I used, sorry, I should have used the command enable, use the shorthand. And so, see, now that we have hashtag mode here, or the pound symbol, this represents privileged exec mode, okay? And so privileged exec, we can do all of our show commands, we can see everything. This is kind of a super user. And then if we want to configure anything, we say configure terminal. Alright, so then configure terminal gives us this conf with the hashtag. And so anything we do here affects, this is global configuration mode, so it affects the entire device. So it's non-specific stuff. Now if we want to get specific, we can go into specified mode, right? And so we say interface, I don't know what we have here, so we'll say F01 for fast Ethernet one. Oh, we don't have one, so let's do a show command, show run. So this is showing my running configuration, and I have gigabit interfaces, so that's what I was looking for. So we do configure terminal again, and we say interface G01, and I could do something like IP address 192.168.1.1.255.255.255.0. Okay, and so now I've set an IP address on that interface. So this is specified interface. If I do an exit, it brings me back to global config. If I do an exit, it brings me back to user or privileged exec, and then our last one is user with just the caret. Okay, so those are our different modes. Primary modes, user exec, right? We just went over that. Privileged exec, the hashtag. Then we go to global configuration in the submodes. I call them specify. They call them, I guess, specific configuration modes. We can program interfaces and different modules. We will get there. We're not going to worry about it too much just yet. Just giving you an example, which I already did. So navigating between iOS modes. So as you guys saw, to get to privilege mode, I typed enable, and it brings up this hashtag. Alright, so then we're in privileged exec, and we want to get out of there, and we could type exit, or we could type disable, and it would bring us back a mode. Another way to get back, we can do Control Z, exit, as we did. Control Z will bring us all the way back to exec mode from any mode. And I think that's about all they're saying there. There's a little video demonstration. Alright, so command structure. This is called the syntax. Alright, so our first command, if you guys see, say we're doing a ping command, which if you don't know what ping is, don't worry, it's coming, but it tests network connectivity. Can we get there or not? And so we type ping, and then our IP address. And really this is a bad example. Let's see if they have a better one. The command show IP protocols, because our syntax can be further than that. So apparently they don't want to go that far yet. So we have our prompt, then our command, a space, and then the specifics of that command. So it's called syntax. We have defaults. You might want to go over some of this stuff. Alright, so the default is what's built into the computer or into the network device. Mode is that mode we were talking about, like configuration mode or privilege exec. History shows the past commands that were issued. Usage guidelines describe specifically how to implement a command. So I'll show you that in a little bit. It's our help command, and then examples. And you could go to the Cisco command reference. It's probably the best. Or they sell booklets if you like a handbook to figure out commands. I prefer this website because as the iOS changes, the syntax can change, and the book doesn't change where the website does. Alright, so context-sensitive help commands. Alright, so we'll bring back up our good old friend router from Packet Tracer, and so you can see this. So if we were wondering, we say enable, right? So we can do some stuff. And say we were wondering what commands there were altogether. Well, that was hard to see, but what I did was I did a question mark. So you do a question mark, and it shows me all these commands. Now, if I want to go a complete page down, I hit spacebar. And so it gave me all of them. And so these are all the commands I can do. There's more commands if we're in the real world, but on Packet Tracer, these are all the commands you can do from global config. Now, say I thought I knew my command, like I said, I can't really remember. My command starts with like TE, but I can't really remember how to spell telnet. Oops. And so I just go TE, no space, and a question mark, and it shows me all commands that start with TE. Okay. I could also do, like, if I just set an R. Oops. Sorry. An R question mark. It shows me all commands I can do from there that start with R. So now, say I wanted to do, let's find a 2-word command. We'll go into interface, actually, because this will make it easier. Oops. So we got to configure terminal to go to interface. So we configure terminal and we say interface G01. And I say IP, and I can't remember, say address. I know it's an IP command, so if I do a space, it shows me all the words I could put in there. So I could do any of these, and of course I wanted address. Alright, so then the help command also gives me this. So I say IP address, and then I do a question mark. And so now it tells me what I have to put next. It says either I can put DHCP, or I can put the IP address, and it says ABC because an IP address is 4 octets. So we could do 192.168.1.1. Alright, and then I do, if I did an enter, it'd give me an error. It says incomplete command. So I go back to that command and I say question mark, and it says, oh, you need ABC as subnet. So I go 255.255.255.0. And then if I wanted to know if there's anything else, I do a space and a question mark, and that CR means there's nothing else. You can press enter. Anytime I see a CR, I can actually just press enter and it will enter that command. And so I hope that's not too much help commands, but that's the help command. And then we had command check. And so I showed you guys incorrect command, but we could go with another, such as, how about we did IP, we need something that starts with an A, and I press enter, and it says ambiguous command. Now the reason it says this because there is IP access group, IP address, and IP authentication. So it's not specific enough to even know what I'm talking about. So then I say IP, let's see, ACC. And so now it's say incomplete command because I needed a complete access group. So that's incomplete, incorrect, I believe. Yeah, the incorrect was the first one. Incomplete and ambiguous. Ambiguous means there's too many options that can't figure out what I'm trying to program. So that's the command check sequence. Alright, hotkeys and shortcuts. You guys kind of already saw me do some of these hotkeys and shortcuts. Okay, so I'll give you an example. So we have down arrow. Well, it's going to scroll through former commands. So I do up arrow, and it actually shows the commands I've typed in the past. Now if I want to scroll back down, I go down arrow, right? You guys might have saw that I type, I say ADD. Alright, so if we look up here, IP address is the only thing that starts with ADD. So as soon as I get one that's all it can be, I can press the tab command and it's going to auto-complete that command for me. Hopefully you saw that. Control A moves to the beginning of the line as such. Control E moves to the end of the line, and Control R redisplays the line. It's not doing anything for me in Pack Tracer. And then Control Z brings me back out to privilege exec mode. And Control Shift 6 is going to interrupt commands. Control C exits some commands. So if you want to get out of, say we did a trace route in the future, you'll see Control Shift 6. Or if you type a command wrong, sometimes it tries to do a DNS lookup, and you're going to have to put Control Shift 6 to stop that. Control C will stop stuff like a ping. Okay, iOS, examine commands. Look through these show commands. You guys are too young in this subject for me to go over them a lot. We're going to go over them over and over again, so feel free to look at them and see what they do in Packet Tracer, but don't get too crazy. The show they're used for troubleshooting. This show version, it shows us all kinds of stuff like what our iOS is, what device we're running, what version of that iOS, what our features are. And if you look right here in the screen, it'll show you even more, and it actually shows more than this. So it shows our flash memory, our RAM, was our bootloader successful. It shows more, and at the bottom of it, it shows our configuration register. So, and you can read through all this: software version, bootstrap version, system uptime, system restart info, software image name, router type and processor type, memory type and allocation, software features, hardware interfaces, configure in the configuration register. And the configuration register, actually, why it's important is it allows you to password reset a router if you get locked out. But anyways, this is the show version command. Why it's so important to you guys this early in Cisco, I don't know, besides that it's a really cool command. Feel free to do some of these labs if you would like to. Okay, so we were talking about routers, and so now we go to switches. And right here we're seeing a 2960 switch. And as you can see, the difference between routers and a switch is a router has only a few interfaces. That one router they showed wasn't a very good one. I will have to show you in class, but a router typically only has, I don't know, 2 to 3 LAN interfaces and probably up to 4 WAN interfaces, so 7, whereas we're going to have 24 to 48 on a basic switch like this 2960. This is a 24 port switch. Some are a 48 port, but they're going to have a lot more switches. They're all going to be on the front, and they're just a little different. But the switch makes up the most basic form of a network device. And so right now, as you guys can tell, what it's talking about here is by default, devices start up as routers and or as let's see if we can get this thing to work. Switch. So all devices are going to be called switches, and so we have to name them because we're going to put them in different rooms, and if they're all named the same, well, same as a person, it would get confusing. And so we do the host name command, and so we're going to name them one way. We would name them as the floor, the room, something like that. And typically industry standard would say SW or RT and then a dash and the floor or the building and the room number, but something real clean like this, not too many capitals. And in our host name we can't have spaces, we can only have capitals and numbers. I don't think we can even have special characters besides the dash and maybe an underscore. So how do we configure this host name? Alright, well, we'll bring our friend the router back, and so let's say we were starting this from scratch. So we're in user mode, so we say enable, and that brings us into privilege exec mode, and from there we're going to say configure terminal. Alright, so now we can configure stuff globally, and the host name is globally, right? It affects the entire device. Alright, we don't have to get specified in it. So then we say, really hard to remember command, host name, and we would say router floor 1, or whatever we want to name it. So that is my router floor 1. And so now you can see that the router here changed to RT floor 1. Alright, so that's a host name. And you guys can try this here if you would like. Securing the device. Alright, so we're going to enable a password, enable a secret, a console password, and a VTY password. Alright, so we're going to bring old router back. And so what an enable password is a password. It's actually a legacy password, and it is a password in a privilege exec because we say enable to get there. Alright, so now we're going to say enable password, and we're going to say password 01. Don't ever use this in a real environment, but we're going to use it here. What did I do wrong here? Oh, I forgot to go into configure terminal. Configure terminal, and then we say enable password 01. Alright, so then what this is going to do is we say exit, exit, and then when we say enable, it asks for a password, and we're going to put in password 01 at that point. Okay, so that's password 01. Or that's the enable password, and this is legacy, and I'll show you why it's legacy is because we say show running config, and I hit spacebar to go down, but I don't have to, and we see right here it says enable password 01. So what that's saying is if someone's looking over your shoulder, they can see exactly how to get into this router, and we don't want that. And so Cisco came up with a different syntax. So we say config terminal, and it brings up our next command, and that is enable secret password 01. Alright. And it's telling me there's an error because I put password 01 and says, hey, this is a bad idea. Well, let's put password 02, okay? And so now it will no longer let me use that enable password because enable secret, and here, I'll show you. I'm trying to type password 01 and it shouldn't work. And it didn't. So I say password 02. And so now enable secret has a higher privilege level, and so if you enable both of those, it will always go with enable secret password. And why is that? If we do a show running now, we see the enable secret and see how it's password 01, but it's been encrypted with MD5. And so that is, we do that so somebody can't just look over your shoulder and do what they want. Okay, so next, our console. So remember, this console is this cable we plug into the back of the router. It's a little blue serial cable, and we plug it in and program the router initially. Well, if someone was to get access to our data closet or cabinet, so I don't know, a janitor rolls in and throws a console in because they're a Russian spy and they want all of our information. If we don't password that, then they would just get straight into here and they could wreak all kinds of havoc or steal our information. So how we do that is we would go back, well, we don't have to go back to user, but I'm just going to for the sake of doing it, and we say enable, and we say password 02 because that was our secret password. And now we say configure terminal, and we're actually configuring the console, so it's a specific, and we say line con 0. Okay, so how do I know con 0? Well, it's always con 0 on the Cisco device, but I could do show or running config, and I hit the spacebar, and I hit the spacebar again. This is scrolling me down a page at a time, and it's got the different things. And I see right here, this is my line con 0, this is my line auxiliary, and this is my line VTY. Alright, so we go into configure terminal again, and we say line con 0, and if I want to password it, it's a hard to remember command of password. Okay, so whatever the password is what I just type password and then the password, so I will say console1. And so that's going to be my console password. So now whenever I console in, I will have to type console, but I also need to type the command login so it allows me to log in, which is actually built in there by default, but we want to do it again. The line VTYs are what allow us to telnet and SSH, and so I'll just give you a real quick telnet one. So we say exit, we go back to configure, and we say line VTY 04. Why do I know it's 04? I can see it right here from the show run. And so it starts with 0. This would be the first one. If I did 1 to 4, the first person trying to telnet would be unsuccessful. So I do 0 to 4. If I did 0 to 1, that would mean 2 people could telnet at a time. This allows me, 0 to 4 allows me to do 5 people to telnet. So I say line VTY 0 through 4. Alright, now I say password, and I say telnet 1. Alright, or whatever you want to put, and log in again just to make sure it's there. I can see it's there already from the running, but what is this allowing me to do? I'll show you. So exit, exit. Now say we weren't on this device and we wanted to go in, I would say telnet 192.168.1.1. That's an IP address I've programmed in this thing already, and we'll see if it works. Fail, it's the wrong interface. Just a second, let me adjust which interface it was in, and because I must have put the IP address on the other one. and I'm having a spanning tree algorithm run on my switch before it goes up, and I will type it in a second. Actually, we will try to ping it first. So I've been talking about the ping command, so I'm going to show you ping 192.168.1.1. I want to see if I can get there, and I can. So now I'm going to say telnet 192.168.1.1, and this is a weird thing because I'm telnetting into a device I'm already in, which you typically wouldn't do, but I would telnet to a different device. And so I type telnet 1, and look at it, put me into user mode, and then I do enable, and I'm going to do password 02, which was my enable secret. Alright, so take a look at what these passwords do and maybe try it out, because we're going to hit it. We are going to do these commands a lot. Okay, so what it's going through is it's going to show us basically what I just showed you guys right in here, the console passwords. Okay, so I did forget one password. Another way to encrypt is, so if we do a show run again, we can go down through here and we see these VTYs, and you see that telnet 1 and console 1 are in clear text, so that whole shoulder thing. So we can actually go into configure terminal, and we want to encrypt all passwords on here, so we do a real simple encryption. So we say service password encryption, and press enter. And so now what that's going to do, let's see if it'll do it without restarting. Show running config. We're going to go all the way down to the bottom, and now they're numbers. So remember, before we could see them in clear text up here, console 1 telnet. Now they're a hashing of numbers. So that's service password encryption. Our next thing we're going to do is called a banner. And so what a banner is I will give you an example. We say configure, we're going to configure a banner message of the day. So configure terminal, and we say banner MOTD message of the day, right? And I could do a question mark to see what's going on, and I think we're going to go. So then what we're going to do is from here we say hashtag, and we say authorized access only. Now, I don't think this will ever actually stop a hacker, but this is your due diligence of saying someone can't say, oh, I didn't know I wasn't allowed to get into my network device. So we never use a due diligence or a message of the day says everyone welcome, because that's the opposite. And so where that's going to show up is if we exit out of all of these. As you can see there, before I'm going into user mode, it says authorized access only, right? So that's what a banner message of the day is. We could schedule downtime, or threaten people, or do what. Alright, so now here's the most important. We programmed all this stuff, but if I was to power down, remember I said this is running in RAM. And so RAM, when it loses power, it's going to stop. But we have this thing called NVRAM, or non-volatile RAM, inside of a device. And what is this? Console? And so we need to get to privilege and save this to the non-volatile RAM. And non-volatile RAM is built into the system, and it's where our what's called the startup config is running. And so we do this at the privilege exec mode, and we say copy, and that thing we were looking at was the running config, and now we're going to copy it to the startup config, okay? And the first time you do it, it says destination file name startup config, because we could save it as other things, but this saves it in that NVRAM so that it will be accessed when we start up. And so there we go, and that's how we save. Copy, we can do that. There's some other commands we can do to save it. We could say let's see if it's supported. Not all commands are supported in Packet Tracer. Write run, that would actually save it on a real device. WR is shorthand for that, and see, that actually saved it. That's shorthand for write run, which is funny that write run isn't actually there. If we said write erase, it would erase everything on this device, so be careful with that. Anyways, so that's what we're doing. Capturing text. Alright, so what is this? I think it's trying to talk about TFTP, possibly? Anyways, anyway, I guess it's saving text from Terra Terminal. We did not do that, so yeah, you can look at this, but there are better ways to get your configuration that we'll talk about called TFTP, so we'll just wait for that. Alright, so address schema. Alright, so we've been talking kind of about IP addresses. So an IP address is kind of like your house address. So there's only so many addresses on your street, and there's only so many IP addresses in a network. And the subnet mask tells us that, but we will be studying that later on. And so we have to give IP addresses to anything on the network that's going to work. So computers, whatever they are, workstations, laptops, file servers, web servers, network printers, voice over IP phones, security cameras, smartphones, anything that's going to be used on the network, it needs an IP address. And this is called IP version 4 address. If you guys have never been to these properties, what you do is you go down to your little your network connection there, or you go to control panel and you go to network sharing. We'll go over it more in the future. So where else do we put IP addresses? And so on switches to manage them, we put IP addresses. On router interfaces, we put IP addresses. But it's talking about interfaces and ports, and we'll cover this more in the future, but it goes back to, remember, media was, we have copper media, fiber optic, and wireless. They plug into switches, and anyhow, the media depends on the distance we want to send it, the environment that it's in, the amount of data, or the amount of speed we need to transfer the data. And there's full chapters on this, so I'm not going to go into this very much right now. Alright, so we're at configuring a switch virtual interface, which this is a horrible time to introduce this. This is called a SVI, a switch virtual interface. And what it is a management interface used to manage a switch. And by default, all switches are on VLAN 1. And so what I mean by that is, okay, so this was that Control-Shift-6 thing. Let's see if it works in Packet Tracer. It does not. Anyways, we're going to wait for this thing to time out, but an SVI is what's used. So on our router, it's a layer 3 device, which is what IP addresses are, so it allows us to put it on the interface. On a switch, if I try to put an IP address on a switch interface, it would tell me I can't do that. And so we use a virtual interface, that, right, we put it on a physical interface on a router, but we put it on a virtual interface on a switch, and it's just used to telnet. That's all it's used for. So if we want to telnet or SSH, this is the address that we're going to use. And this is taking an incredibly long time. There we go. So we say enable. And then we're going to configure it, and we say configure terminal. Actually, we're going to do a show running so I can show you that it's existing there already. Show running. Alright, so you see these interfaces, they don't look like they have anything on them, but on the bottom we see interface VLAN, no IP address, and that it's shut down. So to approve, we say show VLANs, and alright, so up here, all of our interfaces are in VLAN 1 is what this is saying, and it's real sloppy right now for some reason. Anyways, that all interfaces are in VLAN 1 right now. So what's in VLAN 1, F0 through F24, this is 24 port switch, and the G interfaces are as well. So we know everything's in there. So we say config your terminal, and we go to this interface VLAN 1, also known as the switch virtualing interface, the SVI, and from there we say IP address 192.168.1.2.255.255.255.0. Now, why would I say not 1? Because IP addresses, you can't reuse them, and I've already used 192.168.1.1 on the router, if you guys maybe remember. And then I say no shutdown, and as soon as I say that, we see that the interface VLAN 1 is coming down. So the inverse of any command is no, and so if it said shutdown, I say no shutdown. If I didn't want an IP address, I'd say no IP address. It would take that off. So now we have an IP address on here, and so similar to the router, actually we'll go back to the router and we'll show you how a real telnet, oh actually I don't have telnet enabled on there yet. So how do we enable telnet? Configure terminal. And what enables telnet? The line VTY. So we say 0 space 4 again. And switches actually have more than that, but we don't have to turn them on. And we say password telnet 1 and login. So now we can telnet. And so I bring back up the good old router and I say telnet 192.168.1.2, and it says user access verification. I say telnet 1, and look at that, I'm logged into my switch, and so that is me remoting into a switch. Now if you guys would like to try that, you do that there. This interface VLAN 1, I wish they wouldn't talk about it till later because it gets very confusing, because the switch is a layer 2 device, as you guys will soon learn about in the next chapter. Alright, so manual IP addresses or configuration for end devices. We statically set them. Alright, so how do we statically set them? We go here, we right click, open network and sharing, and it's going to bring up a window, and then we click change adapter settings, and it will bring us to a window that looks a little bit like this, and then we say properties on there. So we bring the properties over here and we get this box like they have, and then we click properties again. Okay, and I'm using DHCP, but we could use, this is how we statically set. We put in all of our information, which we'll soon learn how to do, and that is how we statically set. Try it on your own computer. Automatic IP addressing is that thing I told you about, DHCP. And so DHCP will just automatically configure an IP version 4 address and do DNS servers. If you want to statically set your address, you can go to command prompt, and you can say ipconfig, and it's going to show you the IP address that you're using and your subnet mask. If you want to put in your DNS, you just say ipconfig/all. And I have a lot of interfaces on here because I'm doing virtualization and other things, but you'll have DNS servers and everything in between. So it'll give you your IP addresses and then look for your DNS servers, and you can set all of that statically by going down that network and sharing. Go to change adapter settings, and then click on the interfaces. Okay. IP address conflicts. The reason we use DHCP is because when we manually set, there's a whole lot larger chance that we are going to have a conflict, which a conflict would mean we have two IP addresses that are the same. Remember, each address has to be the same. Just like if your house had the same address as someone else, you no longer probably are going to get you don't have a guarantee of getting a package from the mail correctly. Same thing with IP networking. Alright, verifying connectivity. Ping, kind of showed you that already. If it doesn't reply, you're not getting there. If not, you see something like this, like we showed you before. Yeah, so we'll be doing a lot of that, so I'm not going to go into that too much. But you can test it right there if you want to. And this is actually testing the loopback, which is the actual device. It's testing your IP stack when you ping the loopback. Alright, so this is pinging the SVI, which we pinged the router, so we don't need to do that. Actually, I'll just pull it up. We'll do it again. So back to the good old switch, maybe. So we're going to exit and exit. We want to be in privilege exec, and we're going to ping 192.168.1.1, which is a router, and on a switch or a router, we have exclamation points or periods. Exclamation points means it was successful, periods means it failed, such as if we ping 192.168.1.3, which doesn't exist, period, period, period. Okay, so that's what we have going on there. Alright. And that's what this is talking about here. Feel free to go through those on your own and do some pinging. It's a wonderful tool. We will do a lot when we start doing labs, which in CCNA1 we probably will not be doing that many physical labs, but when we get into CCNA2 we will. Alright, so that was chapter 2. Once again, if you have any questions, post in discussions or send me an email. And